Hi, so my name is Sarah Dobreniecki. I'm a senior biologist within the Health Effects Division of the Office of Pesticide Programs at the US EPA. And today I'm going to talk about evaluation of pesticides by the US EPA with a focus on our carcinogenicity guidelines and our guidance documents. So disclaimer before we get started, this presentation was reviewed and approved accordance to the US EPA policy, and any mention of trade names, products, or services does not imply an endorsement by the US government or the US EPA, and the EPA does not endorse any commercial products, services, or enterprises. So an overview of what I'm going to cover today, I'm going to first by talking a little bit about our data requirements for pesticide registration and the flexibility we have in these data requirements. I'm then going to focus in on our carcinogenicity requirements and the guidance documents we utilize within our processes. We're then going to segue into OPP's goal, or the Office of Pesticide Products goal, of reducing animal testing, and how our HAZPOC, or the Hazard and Science Policy Council, fits in with the goals of reducing animal testing. And then finally, we're going to end with discussing the Rethinking Carcinogenicity Assessment for Agrochemicals project. So as far as data needs, so the Code of Federal Regulations outlines our data requirements, and they're dependent on the expected use pattern for the pesticide of interest. So for example, there are different requirements for food versus non-food use pesticides. These requirements also depend on the expected route and the duration of exposure of the pesticide of interest. And so when we're talking about data generation, we have toxicology data, exposure data, we get product chemistry and performance information. And as a result of all of this testing, it can cost millions of dollars to register a new conventional pesticide. And in turn, this requires a large number of animals. So on the bottom of the slide here, there's a link to the 40 CFR Part 158, and this is going to outline all of the data requirements for pesticides. So specific to carcinogenicity testing, on the left-hand side of the slide are guideline studies that we work under. So these are OCSPP Series 870 studies. The 4100, 4200, and 4300. These three studies are our long-term cancer bioassays. So it's typically pesticide exposure through the diet. The animals are exposed for the full term of their life. We typically see one full-term study in a mouse and a second in a rat. Sometimes there's an interim sacrifice within these studies, and then the final sacrifice at the end of the animal's life. And then we're looking for things such as tumor formation, pre-neoplastic lesions, and another number of other endpoints that are outlined in the specific guidelines. And then in addition to those long-term cancer bioassays, we also have a battery of testing for genetic toxicity, and that runs from 5100 up to 5915. Another document that we work very closely with are our guidelines for carcinogen risk assessment. The most recent document that we're working with was published in March of 2005. And this is a really important document. It provides our staff with guidance on how to analyze different pieces of data, things to consider when you're analyzing mode of action and mode of action data. It's really a big weight of the evidence narrative. So it tells us how to pull all of the pieces of data and information we have together in order to paint that weight of the evidence narrative. And it also provides guidance on placing specific chemicals within a cancer classification, which in turn can impact whether or not you're going to need to quantitate cancer risks separately within your human health risk assessment. So within all of these data requirements, we do have some flexibility. So the US regulations gives the EPA substantial discretion to make registration decisions based off of what the agency deems are the most relevant and the most important pieces of data for each action or for each chemical. So as stated in the federal regulations, and this is under section 158.30, studies and data required may be modified on a case-by-case basis to fully characterize the use and the properties of a specific pesticide that's under review for registration. Something important to consider that is that not all data requirements are always going to be considered appropriate. As an example, the properties of a chemical, or perhaps there's an atypical use pattern, could make it impossible to generate the data that's required, or the data would not be considered useful in the agency's evaluation. So as a result of this, under section 158.45, that section really permits the agency to waive specific data requirements. However, we must ensure that we still have sufficient data available to make the determinations that are required under our statutory standards. The 40 CFR also provides the EPA with broad flexibility, and that's under 158.75, to request additional data beyond what's in Part 158. And part of this is alternative methods and approaches being able to be considered and accepted as additional data when deemed appropriate. And so, consistent with the guidance, the director of OPP sent a letter to stakeholders in 2016 on OPP's goal to reduce animal testing. The main objectives that were identified in the letter included a critical evaluation of which studies are used to inform the basis of our decisions, expanding our acceptance of alternative methods, and attempting to reduce the barriers that are associated with the adoption of these alternative methods. The letter also highlights the importance of working in a partnership with a wide range of stakeholders in order to achieve this mutual goal of reducing animal testing. And where this fits in with OPP and waiver requests is at the HAZPOC. So waiver requests are evaluated by OPP's Hazard and Science Policy Council, also known as the HAZPOC. So this is a committee that's comprised of toxicologists and exposure assessors from across different divisions. And the committee provides recommendations on the need for a given study. So these waiver requests allow us to reduce the number of required animal studies that are needed to confidently make a safety finding for a chemical. In addition, the committee also considers proposals for study refinements. So sort of overall, the utilization of this committee for these considerations allows us to build efficiencies into our risk assessment process. So time and resources are not being spent on studies that are not considered critical for the risk assessment, and our staff is really able to focus on the issues and the data that are driving the risk of a chemical. So this committee uses a weight of the evidence approach, and it takes into consideration not only the hazard, but also our exposure information. So we look at such things as physiochemical properties of a chemical, the pesticide's use pattern and how people will be exposed, all of the hazard information that we have available for that chemical of interest. This could include, your standard toxicity testing, but also anything you have available on mode of action and any other information on pesticides that are within the same class as your pesticide of interest, or structurally similar chemicals. And then finally, we really take into consideration the overall risk picture for that chemical of interest when we're making our decisions onto whether or not we can waive a specific study of interest for a chemical of interest. So looping the waiving of studies and the HAZPOC in specifically with carcinogenicity testing, OPP has been actively involved in the development of a guidance document in order to waive some of this carcinogenicity studies. The Rethinking Carcinogenicity Assessment for Agrochemicals project, also known as RECAP, it was a collaborative effort that was led by PETA International, and there were contributions from several other governmental organizations, including the US EPA, as well as pesticide registrations. And the goal of this was to develop a framework for carcinogenicity studies and waiving the need for a carcinogenicity study. This work was published by Hilton et al. In 2022, and there's a snapshot there on the slide of the published literature if you'd like to take a deeper dive. And on the final two slides, I'm going to walk through the recap framework and some of the highlights of that framework. But before we dive into the framework, I want to loop this back to NAMs and the new approach methodologies. So we already know that there are NAMs available or NAMs in development to inform several of the areas that we're going to discuss on the next two slides. Genetic toxicity, PChem properties, mode of action studies, read across. But we do want to note that there is the potential to further improve our current NAMs and or to develop new NAMs to inform the overall cancer waiver evaluation. So this leads us into the actual recap framework. So the first thing to consider when you're reviewing the framework and trying to put your chemical of interest into the framework is the genotoxicity of that chemical. So genotoxicity is an established mechanism of tumorigenesis, and tumors that can be attributed to this mechanism would be considered relevant to humans, and the framework would not be applicable. So the framework is really only applicable for non-genotoxic, non-DNA reactive chemicals. So right off the bat, if you have a chemical that you know is genotoxic, it would not be placed into this framework. We consider the PChem properties. So this allows for reliable read across to structurally similar chemicals or analogs. The structure of a chemical can also provide information or insight into the ADME, the absorption, distribution, metabolism, and excretion of that chemical, or other parameters. An example could be the solubility or the hydrophobicity. Knowing that information about a chemical can influence its bioaccumulation. And this is important information to know because in some cases, there is extrapolation from a subchronic to a chronic duration. So understanding your bioaccumulation or your bioaccumulation potential of a chemical is important. We want to try to understand our exposure as best as possible. So we want to characterize any potential human exposure. We're often asking ourselves, do we have enough information? Do we have enough data to assess the exposure scenarios of concern? We want to have an understanding of the level of refinement of the exposure assessment. An example here, and pulling it back to the overall question as to whether or not we're going to need this study, if you have an unrefined assessment and you don't have any risk of concern, that may significantly impact the decision on whether or not you're going to need a full carcinogenicity long-term in vivo study. Understanding the ADME and TK is important. This can inform the clearance rate or, again, the potential for bioaccumulation with a chronic duration of exposure. It can help identify species, sex, or age differences that may influence your extrapolation of data from an animal to a human assessment. An example here is using a PBPK model or a physiological-based pharmacokinetic model to better understand the internal concentrations in an animal for a comparison to a human exposure in order to better estimate your human risk. Because at the end of the day, the end game is conducting a protective human health risk assessment. Understanding your subchronic toxicity is also very important. So short-term studies can aid in identifying the most sensitive species. It could also help in identify lesions that have the potential to progress with time. So it's important when possible to identify not only the low AL or the lowest observed adverse effect level in the study, but also to identify effects that are occurring at a higher dose level when the effects may progress with a longer duration of exposure. Precursor events often occur at the same or the lower dose level than where tumors are forming. And an example of this is seeing hepatocellular hypertrophy or necrosis prior to or in tandem with the formation of liver tumors. So understanding and characterizing that is really important. And it helps us to make a reasonable prediction of chronic toxicity and then to select a point of departure that's going to be protective for your chronic risk assessment. Understanding hormone perturbation is really important. So there are certain types of hormone perturbations that are known risk factors for cancer formation in humans. An example of this is an increase in estrogenic activity of a chemical after exposure being linked with an increased risk of breast cancer and endometrial cancer in humans. So if you have evidence for a lack of hormone perturbations, it's important to include that in your weight of evidence. Similarly, immune suppression. So this increases the risk of cancer in humans. We know this through the demonstration of an increased risk of certain types of cancers following the use of immunosuppressive drugs. So if you have information showing that your chemical does or does not suppress the immune system, it's important to include that into the weight of evidence narrative as it is considered human relevant. Looking at your proposed mode of action, so when applicable, a greater understanding on the mode of action and your potential targets of toxicity, these type of information and data can be developed proactively in order to increase the confidence in the prediction of your chronic outcomes and the formation, the potential to form tumors. So you can have studies that inform your mode of action, different mechanistic considerations, information on key events within that pathway is important, and sometimes it can and sometimes it may even potentially influence the selection of a point of departure to be protective of downstream effects. Read across is an approach that we use for predicting potential toxicity in the absence of chemical-specific data. So we are filling a data gap for an unknown chemical based on data gathered on similar chemicals. So this approach is not being used to predict an unknown endpoint, but the data that we pull and that we generate are being used in the weight of evidence assessment of chronic toxicity and carcinogenicity potential. And then finally, it's important to consider your proposed risk estimates. So this is pulling together your use pattern, what you know about your exposure potential. It's pulling together all of your toxicity data to make a potential risk determination that's protective of human health. The exposure estimates that you're utilizing should be based off of the proposed uses of the chemical. And important is the selection of a point of departure. And that point of departure should consider all of the data available. So you're looking at your ADME, you're looking at your mode of action data when applicable, your read across results, the entirety of the toxicity database. So we briefly touched on subchronic toxicity, but if you have developmental toxicity data, reproductive toxicity data, any additional mechanistic studies or information on key events, all of that should be pulled together in order to inform your point of departure selection. And then finally, the uncertainty factors are important. So these should be applied in order to account for any uncertainty that you may have in the conclusions that are being drawn. And then all of these pieces are pulled together to form your conclusions for your waiver rationale. So the conclusions should really justify the proposal that you're putting forth and indicate if one or both of the chronic carcinogenicity studies are recommended to be waived or not to be waived. And your conclusions should also address any uncertainties that you have and the qualitative and quantitative strengths of the evaluation. And with that, I want to thank you for listening to the presentation. I appreciate your time and energy.